Hydrogen bonding is an attractive intermolecular interaction stronger than the van der Waals forces. It occurs exclusively when the hydrogen atom is sandwiched between two highly electronegative atoms. One electronegative atom is covalently bonded to the hydrogen atom and the other is attracted electrostatically. The molecules closely associated with the hydrogen bonds are shown as a dash. This attractive force can operate between two different molecules or within the same molecule, and depending on this attribute, we call them intermolecular hydrogen bonds and intramolecular hydrogen bonds. There are 4 common mistakes a new learner in chemistry makes while drawing a hydrogen bond. Number 1, assuming that any electronegative atom can form a hydrogen bond. When choosing electronegative atoms in organic chemistry, we pick those with higher electronegativity than carbon and hydrogen. Of these 7 electronegative atoms without carbon and hydrogen, that is, the atoms of fluorine, oxygen, nitrogen, fluorine, bromine, iodine, and sulfur, only the highest electronegative atoms of fluorine, nitrogen, and oxygen can form hydrogen bonds. However, there are special circumstances in which exceptions to the formation of hydrogen bond with chlorine are possible. But there will never be any hydrogen bonds from a CH hydrogen to an oxygen on another molecule. A CH bond isn't polarized enough for any real attractive interactions which are necessary for hydrogen bond formation. So this understanding opens up several possibilities in the form of functional groups containing oxygen, nitrogen, or halogen atoms such as acids, amides, aldehydes, haloalkenes, and amines to explore for hydrogen bond forming interactions. Here we will use an aldehyde such as acetaldehyde and an alcohol such as ethanol as examples to learn how to draw a hydrogen bond correctly. Number 2, choosing the wrong company. The second common mistake that a new learner makes is in identifying hydrogen bond donor and acceptor atoms. For a molecule to be a hydrogen bond donor, it must covalently bond to the electronegative atoms of oxygen, nitrogen, or fluorine. So in our example, the hydrogen atom covalently bonded to the electronegative oxygen atom in alcohol acts as a hydrogen bond donor. A hydrogen bond acceptor must be an atom that contains a lone pair. So the lone pair of the oxygen atom in acetaldehyde serves as a hydrogen bond acceptor. The hydrogen atom of the acetaldehyde is neither a hydrogen bond donor nor an acceptor. Third, bending it like Beckon. Hydrogen bonds are distance and angle dependent. Too far and bent makes it really weak. Incorrectly drawing the bond angle is the third most common mistake made by new learners. Let me show you 3 examples of drawing a hydrogen bond, only one of which is correct. The ideal bond angle is 180 degrees, which occurs when the hydrogen donor atom and the lone pair of the acceptor atom are in a straight line. When the angle decreases, the strength of the hydrogen bond also decreases. No hydrogen bonds are formed when the angle is 90 degrees or less. This is highly important when considering intramolecular hydrogen bonds. Only a 6-membered ring structure can support hydrogen bond formation with an ideal bond angle of 150 to 170 degrees. 7-membered rings or smaller rings do not form strong hydrogen bonds. The bond angles are highly constrained. 160 to 180 degrees is close enough in practice to maintain that coveted linear geometry between the molecules for intermolecular interactions. Fourth, picking the wrong sides. The fourth common mistake new learners make is drawing a dipole across the hydrogen bond. They sometimes choose the wrong ends to display a bond dipole. These dipoles belong within a molecule and don't cross over or stay apart from the hydrogen bond bridge. Avoid drawing a partial positive and negative dipoles across the dashed hydrogen bond. So guys, these are the 4 most common mistakes and avoiding them is the best strategy for success. Hydrogen bonding is the crucial force that maintains the shape of our DNA and helps bind enzymes to their receptors. By learning and applying this concept correctly, we can give hydrogen bonding the recognition it deserves. If you feel that you have understood the concept correctly, then there is a quiz for you. Choose the correct representation of hydrogen bonding between 2 molecules from the 5 images in the quiz, the link to which I will place below. Subscribe to the study program on Organic Chemistry Fundamentals at CurlyArrows.com/subscribe.